Okay, welcome to the first video in the second unit. Once again, this unit is going to focus on working on skills. The first class period you did factoring and working with your graphing calculator. This lesson is on quadratic review, and so we want to talk about some of these things, especially, and most of this will be a reminder, and I'll let you know which part of this that you need to write down and which you don't. So if you have a coordinate, x and y, you remember that x is the independent variable and y is the dependent variable. In other words, whatever x is, y depends on it. So you plug x in, you get y out of the function. Y, remember, is just another way of writing this in function notation is f of x. All right, so the dependent variable depends on the independent variable. If you have a parabola, the parent function for a parabola is f of x equals x squared. And it looks something like this. X squared, this is decreasing to a minimum and then increasing afterwards. Remember that then if I reflect this parabola across the x-axis, this would be negative x squared. Then this would increase to a maximum and then decrease after that. So I have a max and a min with a parabola. You will be given this particular notes in class, so don't spend a lot of time writing down a lot of the words. What I would write here is the diagram. Right here, this diagram, and then also these three things so that you can get to your notebook when you get that in class and copy those in. You'll notice you have a parabola, not centered at 0, 0. This is a minimum point. This is the vertex of the parabola. And if you'll look up here at the top, the vertex are the letters H and K, HK, alphabetical X and Y. The y-intercept is here. This is 0, C. And these are the roots. Sometimes roots are called zeros or solutions, depending on how they're written. These could also be called factors. So those are vocabulary words that you need to know, but this is, I'll call this one r sub 2, 0, although it doesn't matter, it's just the roots. And so those are diagrammed. Okay, we have three forms of a quadratic formula. Just like when we talked about linear functions having different forms, quadratic functions also have different forms. The standard form for a quadratic equation is f of x equals ax squared plus bx plus c, where c are coefficients, and a cannot be 0. No, in other words, there has to be a quadratic term in here. To find the x-coordinate of the vertex, you would use this formula with it. You would say x is equal to negative b over 2a. So be sure and write that down. The vertex form of a quadratic equation looks like this. It's very similar. It also has an a, but after that it's different, and we're actually going to find this later on by completing the square. But you'll notice it has different letters, H and K, and they correspond to the vertex in the problem. And then these two A's are the same number. Those are the same number. If it's positive, it's a smiley face, and if it's negative, it's a frown, which is a very rudimentary way of saying that, but it's very descriptive. Factored form looks like this. Same A, only this time I'm going to write it by its factors or its roots. And so that's what that looks like. I could multiply that out and it would look like standard form. I could multiply out the vertex form and get standard form. Once I get standard form, I can factor it to get factored form. So this is really important for you to remember. I'm just going to mention this on here. To find a max or a min on a calculator in a quadratic equation, you would put the equation that's given into y equals, and then you would put this in y equals in your calculator, And then you would actually use the second trace, and then you're looking for max or min. And you need to know whether it's a max or min to be able to find it. Min, that is not working right. I think you can figure out what it is. If it's asking for the coordinates of the vertex, then you would actually write it like this, HK. If it's asking where is the min, then you just want the x coordinate. And if you want what is the min, then you want the y coordinate. And we'll do more of this in class. I don't know if you'll find this screen helpful or not, but this has all the directions on here to find a quadratic regression. It should be a review depending on what you did in Algebra 2 and what we've done so far, but maybe not. Quadratic regressions are fitting functions to data, and the data is entered in stat on your graphing calculator. So stat edit is where you're going to enter the data. Then you do stat, go back to the home screen and do stat calc and do a quadratic regression. This other is what you do when you're trying to put the function, the actual function, into y equals. And some sundry other instructions here are zoom 9, which is going to allow you to see the entire thing without manipulating the window, and turning the plot on, which allows you to graph it in the first place. If you don't remember this, we probably are going to need to do it more in class. But on the next screen, I'm going to show you what a problem looks like so that you can see what that looks like. So this is a problem that you will be given in class. And usually when you're given a regression problem like this, you get some kind of table. And usually the size in inches is going to be your independent variable, and the price is going to be the dependent variable. And so when you put this in your calculator, this is going to be L1 and this is going to be L2. So what you would do is you would put the size in inches in L1, you'd put the price in L2, and then you would do a quadratic regression and write down the equation and then read through that. So don't copy all of this down, but this is the type of problem that you're going to be doing in class. Okay, here is a problem that you're going to do, and you're going to write the equation in vertex form. That's what this is, vertex form. And so in order to have vertex form, you need two things. You need A, which tells you vertical stretch or shrink. It also tells you if it's a reflection over the x-axis or not. And then you need the vertex, and the vertex is HK. So A tells you stretch or shrink, and then whether it's a reflection. All right. So this one is not a reflection, so A is going to be positive. I have 3 points that are listed on here. You can see them here, here, and here. I don't know if you can see that or not. The vertex on this particular function is going to be 0, 0. That makes it easy. All right, so I know what H and K are. H and K are both 0 and 0, and then I need A, right? So I have y equals A, x minus 0 squared plus 0. So do you have to write the zeros? No. I'm going to have y equals ax squared. Pick a point that's not the vertex, and here's a point here. Let me change colors, maybe you can see it better. Right, that's over 1 up 3. So I have the point 1, 3 that is on the parabola. So 1 is x, y is 3, and so I'm going to put that into my equation to solve for a. So I'm going to have a is equal to 3. So the final equation is going to be y equals 3x squared for that particular equation. This is the second example on the worksheet that we did. And one thing I'd like to talk about is, remember the parent function for a parabola is f of x is equal to x squared. And remember that a parabola can get moved left, right, up, and down. So the vertex, if you look at the vertex on this graph, it's over 2, up 1, 2, 3, 4. So the vertex of this is over 2 to the right, up 4. So when you're looking at the vertex form of this equation, and I'm just writing it, I'm not talking, it looks like this. H and K are the vertex. So what you have is f of x is equal to some number a, x minus 2 to the right 2, and up 4. Now, on most parent functions, this, if they just move them right, left, up, and down, it doesn't change the vertical stretch or shrink. So the a doesn't change. And further, this graph doesn't go upside down like a frown, so it's not negative. So we know for sure that a is positive. We know this because the graph goes up like this, so a is positive. Another thing we know is that on just a regular x squared graph, if it were centered at 0, 0, we would go over 1, up 1 from the vertex. So over 1, up 1. And if that point is on the graph, a is 1. If it's not, then you would pick a point on the graph, and I would pick something like 0, and I think it's 1, 2, 3, 4, 5, 6, 7, 8, 0, 8 is a point on there, or another point would be 4, 8. You can see them marked on there. This is a point on the graph. It has an x coordinate and a y. And so what you would do is you would put the x coordinate back into this equation, put the y back in for f of x, and solve for a algebraically. When we do that on here, we would have 8 is equal to a 0 minus 2 quantity squared plus 4. This would be 8 minus 4, and this is negative 2 squared, which is 4a. So I have 4 equals 4a, a equals 1, and we're back to where we were. So the actual equation for this would be f of x is equal to 1, x minus 2 quantity squared plus 4. And that's it. Those are the first two on that sheet. So when you get to class, you'll work the rest of them. And this is a lot more work than you need to show. But use the parent functions to determine the equation. See you in class.